This is 6.6 part 2. We're going to continue with the problem C over here, find the maximum height of the rocket. We're completing the square in order to find the vertex. So we had our next step here was h is equal to -5 t squared minus 22t over 5 plus 121 over 25. And then this here has to come out and be multiplied by the a value there. So that was going to be, if you do that multiplication, just to show you off to the side here, we'll have -121 over 5 times -5. And what you'll notice is that negative, that will cancel out and become positive. It's over 25. The 5 cancels out here, and this becomes a 5 at the bottom there. So that'll be plus 121 over 5 plus 15. And then I can just factor and simplify. So we have -5, and we know we have to do the factoring here. We can do the perfect square here. So basically, the sign here is negative, so that's going to be negative. And square root of this is going to be 11 over 5, right? So if you do square root of 121 first, square root of 25 first. This is not part of this equation. I'm just showing you what work I did to get to this here. And then 121 over 5 plus 15. So if I put them on the same common denominator, if you do 5 times 15, that should be 75. So 75 over 5, which is 75 plus 121, which is 196 over 5. So we have plus 196 over 5. And so what does this mean now? Well, we have our vertex value. Our vertex is going to be, will be 11 over 5, 196 over 5. So what we know is that our maximum will be reached at this time here, 11 over 5. So 11 over 5, you know that that's 2.2 seconds. So this is 2.2 seconds. But what is the maximum height? It's 196 over 5. Now, usually you want to keep it as a fraction. But if we were, let's just take a look at what that is in decimals. So 196 divided by 5, about 39.2 meters. And it's a terminating decimal, so that's fine. 39.2 meters. You would write a therefore statement. Therefore, the max height is 39.2 meters. And so let's go back up to our graph to interpret that carefully. So we had said that that happens at 2.2 seconds and it's 39.2 meters. So basically over here would be our max height at 2.2 seconds, and it's 39.2 meters. Remember, we said that the rocket would pass a window of a height of 10 meters after 4.2 seconds, so that was after the vertex as we had predicted. And basically all we did was solve the problems using information from the function by finding different parts, zeros or vertex, so on and so forth. I'm going to show you one last method to find the vertex that also works, but typically I want you to find completing the square. If you need to do it for a multiple choice, this might be a little bit quicker for you as well. So one interesting way to find the vertex is to look at the b value in your equation. So let's go back and take a look at that. The b value in our equation is 22. So the b value in our equation is 22. Now, with the b value being 22, we can use that to find the x value of our vertex. We can use it to find the x value of a vertex. And an easy way to use the b value to find your x value of your vertex, and so this is just additional work, let's call this an aside to show you a different technique. you can do minus b over 2a. This would be the x value of your vertex, the axis of symmetry, in other words. So in our case, x would be equal to minus 22 over 2 times the a, which is negative 5, which is negative 22 over negative 10, which is equal to 11 over 5. So notice how we found the x value for the axis of symmetry by using this technique here. And then if you want to find your y value, you would simply have to plug this into your standard form to find the y value. So you wouldn't have to have completed the square if you use that technique as well. So this is another way to find the vertex when you have a standard form and you're in a rush and you want to use it, for example, for multiple choice. You can go ahead and do that. And just to show you quickly on how you would do that with standard form, so we had y is equal to negative 5t squared plus 22t, and then my c value was, what was it again? Let's go back and take a look. Plus 15. Plus 15. So if I plug this into my t, I will get the y value that I expect, the 196 over 5. Let's just try that out. So y is equal to negative 5 times 11 over 5 squared plus 22 times 11 over 5 plus 15. So that means that y is going to be equal to minus 5 times 121 over 25 plus 22 times 11 over 5 plus 15. Let's simplify a bit more here. So if we cross that out, cross this out, we get negative 121 over 5 plus we have our 22 times 11, which is 242 over 5 plus 15. And so minus 121. So now we get y is equal to 121 over 5 because of minus 121 and plus 242 plus 15. And we get y is equal to 121 over 5 plus 75 over 5, which is 196 over 5, which is our vertex value there. So that's another technique you can use as well. Again, from the standard form, to find your axis of symmetry, you simply do x is minus b over 2a, and you know the axis of symmetry would be the x value where the y value is at its maximum or its minimum, depending on the shape of the parabola or the opening of the parabola. So let's go try our next question, question 2. The volunteers at a food bank are arranging a concert to raise money. They have to pay a set fee to musicians plus an additional fee to concert hall for each person attending the concert. The relation is this here to model the profit, P in dollars, for the concert, where N is the number of tickets sold. How many tickets must they sell to maximize their profit? So again, this is a situation where you have to find a maximum. In other words, by now you should know that that basically means your vertex. You need to know that that's your vertex. And specifically here, we are asking for the number of tickets they need to sell. So you're looking for the x value of your vertex. The y value would be your profit, and the x value would be your number of tickets sold. Right? And the reason I know that is because P is equal to, that's profit is equal to, which is my y is equal to, in other words. So think of this like as a y is equal to, and think of this as an x squared, and an x over here. So here we're asking how many tickets, the n value of the vertex, the x value. Okay. We often represent the vertex as hk. We're looking for h, which is the x value of our vertex, which happens to be represented by the letter n in this case here. So a nice easy way to do this would be to complete the square. So let's first model our equation. This is our equation over here. Let's sketch it out. So this would be our profit here. This would be our number of tickets sold over here. And you'll notice that if we don't sell any tickets, we actually start off in the negatives because we already paid a bunch of money to start this concert. So we'd be all the way in the negatives here. Our parabola opens from the bottom. But the idea is that we'd sell tickets, eventually we'd break even. We'd get to a high point here. And then there's a point where after our peak, we'd come back down. But we'd have some break-even points around here and here. And again, that's because we have a set fee for the musicians, but also an additional fee to the concert hall, for each person that attends the concert, which explains our parabolic model here. That's why it's not linear, always going up for every ticket sold, because there's fees that we have to pay as well, right? So it costs money to organize something, and if you want to make a profit, you got to create that model to see what the sweet spot is to break even, but also to reach that maximum as well. Otherwise, if you have too many people, then you're paying too many fees, and you're not getting as much money back for that because you're paying more fees for the people you have, so it's not worth it. So we want to find this. Specifically, we want to find how many tickets get us that. And this point here would be basically, if we didn't sell anything, we'd be negative 48,000. So we would have lost that much money. You sell a little bit, keep going up until you get to your maximum. So let's find out what that is by completing the square. So we're going to do completing the square to find our vertex. We won't have time to finish the problem in this video, but we will complete it in the next part. So we'll start at least. So P is going to be equal to, let's put these in brackets, negative n squared plus 580n minus 48,000. Let's take out the negative from the n squared. So negative n squared, that becomes negative 580n minus 48,000. Let's find the term that we have to add to make this a perfect square. So negative n squared minus 580n. And then the way we do that is we do 580 over 2 squared. So 580 divided by 2. And then we square that. So that's 290 squared. And we get 84,100. So plus 84,100 minus 84,100 minus 48,000. This term has to come out and be multiplied by a. So we get P is equal to negative n squared minus 580n plus 84,100, and then plus 84,100 minus 48,000. And now we can factor and simplify. So we have n, there's a minus here, so that becomes minus, and then square root of this 84,100 is 290, so minus 290 squared. Let's make sure that squared is there. Did I forget it up here? Just double checking. No, I didn't. Good. So squared. And 84,100 minus 48,000. We get plus 36,100. And so we're looking for how many tickets we have to sell. Therefore, we must sell 290 tickets.